Alright, in this video we are going to look at how we can use some periodic functions to model different situations. In this specific example we have a shoreline experiencing high tide and low tide throughout the day. The low tide is 1.1 meters and that occurs at 2 a.m. and at 2 p.m. every day. And the high tide is 5.3 meters and that occurs at 8 a.m. and 8 p.m. So the first thing we want to do is graph this tidal occurrence over a 24-hour period, so over one day. And then we're going to answer some questions about it and come up with the actual equation that would model this situation. So at the bottom we're going to have our time. Okay, we're going to do a 24-hour, so we're going to do one day, so 24 hours. I'm going to start at midnight. Okay, so we'll just call that midnight 0. Okay, but that's my midnight hour. And then I'm just going to make every single one 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This 12 is noon, right? And then I'm just going to actually go with our time system. So we'll just call this 1 p.m. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we're back to midnight again, so this would be midnight. Okay, so we've got the AM time slots over here, the PM time slots over here. And then over here we're going to have our depth, the depth of the water. And the high tide is 5.3 meters, so I just need to make this include that value. So what I'm actually going to do is see if I can space this out to where each box is 1 meter. That'll give us enough space here. I'm actually going to do a little bit of a break in the graph. I'm going to start at 1 here, and then I'm actually going to make every box, every 2 boxes be a meter from there. So if that's 1 meter, here is 2, 3, 4, 5, and then 6 would be way up here at the top. Okay, so I can do that if I put a break in. I can have that first initial distance be a little bit different there. Okay, so what we know is that at 2 a.m. and at 2 p.m. we hit low tide, which is 1.1 meters. So we're going to be just above the 1 meter mark at 2 a.m. and again at 2 p.m. And then we are going to hit high tide, which is 5.3 at 8 a.m. So 5.3 is going to be about here at 8 a.m. and again at 8 p.m. Okay, so I've got 4 points. Now how I know what to do with this from this point is that I know that this is what we call a periodic situation, because the very next day we would have this same thing going on. That we'd have the low tide of 1.1 meters at 2 a.m. and 2 p.m. and the high tide being the same thing at the same times as well. So what's going to happen is it's just going to continue on in this fashion over and over and over again, which is going to give us this nice cosine or sine wave is what we will call it, to model this situation. And again, it would continue on in the same direction. Okay, so there's our graph, and now we're going to answer some questions about it. And the question is that if we have, in order for the boat to be safely docked, we need a depth of at least 3 meters. During approximately what time of the day can the boat be safely docked? So we want to look for, at 3 meters, over what time slots does that happen? And I was a little off with part of the graph here. But we first go above 3 meters at around 5 a.m. So you'll see it around 5. We're initially over the 3 meter mark. And then we go below 3 meters. What I have drawn here is around noon. I'm going to fix that part of the graph just a little bit here. That should be a little bit closer to going through at 11 versus going through at noon. Make that look a little bit better there. So we're going to say 5 a.m. to 11 a.m. Because we see at 11, again, we're hitting 3 meters. And then around 5 p.m. to around 11 p.m., we have the same thing going on. So from 5 to 11, both in the morning and at night, the boat could be safely docked. We'll have a depth of above 3 meters at that point. Okay, so now this is the main part of what we're doing here, and that is to come up with the equation that models this situation. So I've drawn a curve that is either a sine or cosine curve, and I can really choose whichever one I want that to be. But I've drawn this sine or cosine curve, and now I'm going to come up with the equation that represents what we've got going on. The first thing you're going to do is you actually get to pick whether you're going to do sine or cosine. So what you want to look at here is, do you want your graph to look like a sine wave, or do you want your one cycle your graph to look like a cosine wave? And that's totally up to you. This is what we looked at in class in terms of a snapshot of the sine graph and a snapshot of the cosine graph. I'm going to choose cosine, and I'll explain why here in just a second. But I'm going to do cosine, and that is because I can clearly see the top of my graph, and so that gives me a good starting point, whereas sine, I have to start sine at my midline, right? And I don't necessarily know what that midline is. I can find it, which I'm going to in just a second, but because I can very clearly see where that top of that graph is, I'm going to look at cosine, and I'm specifically going to focus on this one snapshot right here, and that's what I'm going to write the equation for, is that one little snapshot of cosine. Alright, so what do we need to know? We need to figure out what A is, what K is, what B and C both are. We need all of that. So my hint to you is to start with C. So if we're going to start with C, C is our vertical translation, right? Our vertical shift. How much was this shifted up from our original x-axis, our midline here? So what I need to do is I need to figure out what the middle of this graph is. What y value would give me the middle of the graph? Well, I know the very top of the graph is at 5.3 meters, and I know the very bottom of the graph is at 1.1 meters. Those are the high and low tides. So I can find the middle by simply averaging those two numbers. So to find C, I'm going to take the high tide number plus the low tide number, and I'm going to divide by 2. And that's going to give me 6.4 divided by 2, which is going to give me 3.2. So that is going to be our C value. The next thing I'm going to do is figure out A. So A, recall, is the amplitude, and the amplitude is the distance between the midline and the top of your sine or cosine curve. So if I know the midline happens at 3.2, so I'm just going to draw that line in. That's going to be around here. If I know that midline is at 3.2, the question is, what is this distance here? And to figure that out, I simply have to take the high value, which is 5.3. That's the very top of the graph. And I need to subtract my midline, which is 3.2. And that gives me an A value of 2.1. Okay, next we're going to move to B. So B is our phase shift. So what we're going to say is, well, we didn't start our cosine curve at the y-axis at 0. We have that shifted over. So the question is, what is that shift for our initial y value there at the top? And that means that we're starting at 8 a.m. Because that's where we hit high tide for the first time. So I'm going to say that our B value is at 8 a.m. Okay, so I'm gonna use 8 for B. Now again, I do need to stress that all of this is going to be different if you choose the sine curve or if you chose a different starting point. So I'm looking at this point right here being my starting point, But you could start with this point and do a cosine curve. Or you could possibly start with this point and think of it as a negative cosine graph and look at one period where it starts at the bottom and then ends at the bottom. So there are different places you can start. I'm writing the equation where this high tide value at 8 a.m. is my starting x value, and that's the equation I'm going to come up with. You could obviously have one that's different. The numbers will be different, but we'll get the same exact graph when we graph this because it's a periodic function. The last thing I need to do is figure out k. So k, recall, is to help us figure out what the period is. So to figure out the value of k, I need to figure out what the period of this graph is. So how long does it take it to go through one full cycle, right? How long does it take to go through one full cycle? Well, it starts at 8 a.m. at the top, and then it goes back to the top at 8 p.m. So what was our period of that? That's going to be 12 hours, right? In 12 hours, we're going to repeat the exact same values again. So if we know that the period is 12, then the k value, remember, is 2 pi divided by k. That's going to equal the period, which is 12. And so to figure out the k value, I'm just going to have to solve this equation. So if I multiply the k over, that's going to tell me that 2 pi equals 12k, and then I'm going to divide by 12, which means that k is going to be pi over 6. Okay, so I've got all my information. I can write my equation. And again, I'm going to use cosine here. So cosine y equals the a value, which is 2.1, times the cosine of k, which is pi over 6, times x minus b plus c. And that equation looks really complicated. I've got decimals, I've got a pi over 6, but what we have here is the equation of this curve, and I could use this if I want to know, hey, what is the depth of the water at 7 a.m. and I could use this formula to figure out what that depth would be at 7 or at any hour. Okay, and so that is the equation of our cosine curve that represents this periodic model for the high tide and low tide of a certain shoreline.